Hello class, you're welcome to our chemistry class. And in chemistry, we shall be looking at the topic volumetric analysis. So what is volumetric analysis before we proceed into the calculation aspect? Volumetric analysis involves accurate measurements of volumes of reacting substances. Now these substances are in solutions and they are prepared by dissolving them in a known volume. So these solutions are prepared by dissolving a known mass of a solute in a definite volume of a solvent. Now, the mass of the solute is usually measured in grams, and the volume could be in centimeter cubed or dm cubed or liter. And so we're having that if you have the volume could be in centimeter cubed or in dm cubed or in liter. Now it's important to understand how to convert from one unit to the other. So from here we have that 1000 cm cubed is equal to 1 dm cubed, and that is also equal to 1 liter. So if you understand this, you can easily convert from one form into the other. And then we said that the mass of the solute could be in grams or it could be in moles. Now there's a way you can convert from a mole to the grams. So we have that the concentration in mole per dm cubed is equal to concentration in gram per dm cubed over the molar mass. So from here you can easily understand what standard solution is. A standard solution is a solution whose concentration is known. For instance, if you're told that you have 5 grams per dm cubed, it means that you have dissolved 5 grams of a solute in 1 dm cubed of a solvent. That is what it means. Or you may be given something else. It may not be 1 dm cubed all the time as far as we're talking about standard solution. Then we talk about molar solution. A molar solution is one where 1 mole of the solute is dissolved in 1 dm cubed of the solution. An example of this is if you have 1 mole of sodium hydroxide which is dissolved in 1 dm cubed of a solution. Alright, so let's solve some questions under volumetric analysis. We have to calculate the concentration of each of the following solutions in moles per dm cubed. A. 14 grams of potassium hydroxide in 1 dm cubed. B. 5.3 grams of sodium trioxocarbonate 4 in 500 cm cubed. And C. 5.8 grams of sodium chloride in 2 dm cubed. Here, we want to calculate the concentration in mole per dm cubed. Alright, so this is our focus, mole per dm cubed. But here, we're given that 14 grams was dissolved in 1 dm cubed of the solution. And we have a base, which is potassium hydroxide. Alright, so this is already in gram per dm cubed, that's 14 grams per dm cubed, and this is a standard solution. Now the next thing is for us to find the molar mass of potassium hydroxide. Alright, so the mass of potassium is 39, oxygen is 16 plus hydrogen which is 1, and when we add this it gives us 56 grams per mole. So here is the molar mass of the base which we are given, of the alkali which we are given. And so we have that concentration in mole per dm cubed equal to concentration in gram per dm cubed over molar mass. And so that is 14 over the molar mass, which is 56. Now when we divide this, that gives 0.25 mole per dm cubed, which is also equal to same thing as 0.25 molar. That is the capital M. And when you have that capital M, it means 0.25 mole in 1 dm cubed. Yes, the B part says 5.3 gram of sodium trioxocarbonate 4 in 500 cm cubed. Alright, so for this one, we're given 5.3 gram in 500 cm cubed. Now we need to make this a standard solution. That is, we need to have it in 1000 cm cubed. So how do we do that? Since we have 5.3 gram in 500 cm cubed, how many grams are we going to have in 1000 cm cubed? So it's more like what to do is to cross multiply. That is 500 multiplies this and then this. So we have x equal to 5.3 times 1000 over 500. And so it's more like multiplying it by 2. So 5.3 multiplied by 2, that gives 10.6 so gram per dm cubed. Alright, so that is already gotten. Now we have to look for the molar mass. Molar mass of our salt, which is Na2CO3. The atomic mass of sodium is 23 multiplied by 2 plus carbon, which is 12, then oxygen, which is 16 multiplied by 3. And so we have 46 plus 12 plus 48, and that gives a total of 106 gram per mole. So now we have it that our concentration in mole per dm cubed will be equal to the concentration in gram per dm cubed over the molar mass. In gram per dm cubed, we have 10.6 over the molar mass, which is 106, and that gives 0.10 mole per dm cubed, or 0.1 molar. So that is the answer. All right, and then the last question under this first one says 5.8 gram of sodium chloride in 2 dm cubed. So that's 5.8 gram in 2 dm cubed, which is 1000, which is something as 2000 cm cubed. So to find what it will be in 1 dm cubed, it's more like dividing by 2. So we have 5.8 divided by 2, and that gives 2.9 grams per dm cubed. Next is to find the molar mass of our salt, which is sodium chloride. So sodium is 23, chlorine is 35.5, and that gives a total of 58.5 grams per mole. Here is the molar mass. So the concentration in mole per dm cubed equal to concentration in gram per dm cubed over the molar mass. The concentration in gram per dm cubed is 2.9 over the molar mass, which is 58.5, and that gives 0.05 mole per dm cubed, which is approximated, or 0.05 molar. So that is the concentration in mole per dm cubed. Alright, so we have a next question which says calculate the mass of the solutes present in each of the following solutions. A. Sodium hydroxide in 250 cm cubed of 0.5 molar solution. B. Hydrogen chloride in 500 cm cubed of 0.1 molar solution. And C. Calcium chloride in 750 cm cubed of 0.1 molar solution. So in this question, we need to take heed to some things. Now the first one says we have sodium hydroxide in 250 cm cubed of 0.5 mole. Now in this question, we're given 0.5 molar. 0.5 molar. And what does 0.5 molar mean? It means 0.5 mole in 1 dm cubed. And 1 dm cubed is the same thing as 1000 cm cubed, right? But we're told that we have the sodium in 250 cm cube of this. So not this entire 1000 cm cube. It is 250 cm cubed of it. So we have to find how many moles we have in 250 cm cubed. And that is more like dividing 1000 by 4. But then let's take it up like this. So we have that x equal to 0.5 multiplied by 250 over 1000. Here we will have 0.125 mole. So that is what we have inside 250 cm cubed. Now we're now to calculate the mass of the solutes present in this 0.125 mole. There's a formula that tells us about the mass present, which is number of moles equal to mass over the molar mass. So here is what we are looking for, the mass which is present in it. Molar mass of the salt, molar mass of sodium hydroxide. Sodium is 23 plus 16 plus 1, and that is 40 gram per mole. Our mass equal to number of moles times the molar mass. Now the number of moles here is 0.125, and then the molar mass is 40. So when we multiply this, that yields 5 grams. So this is the mass of sodium hydroxide in 250 cm cubed. Alright, so here is the big part of the question. It says that hydrogen chloride in 500 cm cubed of 0.1 molar solution. So we have 0.1 molar solution, which means 0.1 mole in 1000 cm cubed, right? And then in 500 cm cubed, how many moles are we going to have? That's more like dividing by 2, which is x. So we say that x equal to 500 multiplied by 0.1 over 1000, and that gives 0.05 mole. All right, now we have to look for the mass of the solutes present in this 0.05 mole. Now we have that number of moles equal to mass over molar mass. Now, molar mass of hydrochloric acid, HCl, that's hydrogen is 1 and chlorine is 35.5. That gives 36.5 gram per mole. So with that, we can find the mass, which is equal to number of moles 0.05 multiplied by molar mass, that is 36.5, and that gives 1.825 grams of HCl. Alright, so in this next one, we have to find the mass of solutes in 750 cm cubed of 0.1 molar solution of calcium chloride. And so we have 0.1 molar, which is 0.1 mole in 1000 cm cubed. But in 750 cm cubed, how many moles are we going to have? When we cross multiply, x multiplies 1000 and 0.1 multiplies 750. So we have 0.1 multiplied by 750 divided by 1000. And when we multiply this gives us 0.075 mole. So here is the number of mole that we have in 750 cm cubed. Next, we have to find the mass of calcium chloride. So we have molar mass of calcium chloride. Calcium is 40 and chlorine is 35 multiplied by 2. And so we have 40 plus 71, giving us 111 gram per mole. So the mass of solutes, it needs to be the molar mass times number of moles. Molar mass is 111, number of moles is 0.075. And when we multiply this gives 8.33 grams of calcium chloride solute. So here is the answer. Here comes the next question, which says, calculate the number of moles of the substance present in each of the following solutes. A. 250 cm cubed of 0.4 molar tetraoxosulfate 6 acid solution. B. 1 dm cubed of 0.25 molar potassium hydroxide. And C. 125 cm cubed of a solution containing 3.65 gram of hydrochloric acid per dm cubed. Now this question is quite straightforward. Now in the first part, we have to find number of moles in 250 cm cubed of 0.4 molar. So 0.4 molar is 0.4 mole in 1000 cm cubed. Hence, in 250 cm cubed, how many moles are we going to have? And that's 0.4 multiplied by 250 over 1000. And so the answer is 0.1 mole. That is the answer to that question. The B says that in 1 dm cubed of 0.5 molar potassium hydroxide. Now this is also straightforward. We know that 0.25 molar of potassium hydroxide is 0.25 mole in 1000 cm cubed. And we know that 1000 cm cubed is also the same thing as 1 dm cubed. And so the question now is that how many moles do we have in 1 dm cubed? This is still the answer. So the question says in 1 dm cubed of 0.25 molar. And so the answer is still 0.25 mole in 1 dm cubed of potassium hydroxide. And now the C part of the question says 125 cm cubed of a solution containing 3.65 gram of hydrochloric acid per dm cubed. Now in this question, we are given 3.65 gram per dm cubed of hydrochloric acid. Now in this one, we're not given in molar. So what we will do is to convert it from gram per dm cubed into mole per dm. So first is we'll find the molar mass of hydrochloric acid, which is 1 plus 35.5, and that gives 36.5 gram per mole. Hence, concentration in mole per dm cubed equal to concentration in gram per dm cubed over the molar mass. So in gram per dm cubed, we have it at 3.65 over 36.5, and that gives 0.1 mole per dm cubed. Now we have it in molar now. So we have to find number of moles in 125 cm cubed. So if in 0.1 mole, we have 1000 cm cubed. How many mole are we going to have in 125 cm cubed? We can cross multiply. That's 1000 multiplied by x equal to 0.1 times 125. Hence, x equal to 0.1 times 125 divided by 1000. When we multiply this through, it gives 0.0125 mole in 125 cm cubed. This next question says we should calculate the mass of hydrogen and tetraoxophosphate 5 ions present in 250 cm cubed of 0.2 molar H3PO4 solution. Now, we're given 0.2 molar of H3. Now, that means 0.2 mole in 1000 cm cubed of H3PO4. Therefore, in 250 cm cubed, how many mole are we going to have? We'll cross multiply, and we have 1000 multiplied by x equal to 250 times 0.2. Hence, x equal to 250 multiplied by 0.2 over 1000. And so this gives 0.05 mole. Now we are to find the mass of hydrogen ion and tetraoxophosphate 5 ion. Now the first thing we need to do is to dissociate this acid into its ionic form. And when we dissociate it, we have H plus and PO4 minus. We have 3 over here. So 3 over here, that's 3 of hydrogen ion, and PO4 takes minus 3. So as to balance the ion, that's 3 plus and minus 3, which balances to give 0. Now with this, 1 mole of this weak acid produces 3 moles of hydrogen ion and 1 mole of tetraoxophosphate 5 ion. So we have 3 moles of H plus and 1 mole of PO4 3 minus. In the question now, we have 0.05 mole of H3PO4. So meaning that 0.05 of this will produce 0.05 mole of PO4 as well. So 0.05 mole of H3PO4 will give us 0.05 of PO4, whereas 0.05 mole of this same H3PO4 will produce 3 times 0.05 of H plus. With that in mind, 3 times 0.05, that gives 0.15 mole. Now next thing is that we'll convert this into mass. When we have that, number of moles equal to mass over molar mass. So we say that mass equal to number of moles times molar mass. So we'll be using the molar mass of each of the ions. So over here, let's do the one of hydrogen ion first. So for H plus, so the mass will be number of moles of hydrogen ion is what? 0.15. So that's 0.15. What is the molar mass of hydrogen? We have just 1 hydrogen there, so we have it as 1. So that's all right. So we multiply this, and that will give us 0.15 gram of hydrogen ion. Then we'll do that of PO4. But before we do that of PO4, we need to find out the molar mass of PO4. Here, PO4, potassium is 31, oxygen is 16 multiplied by 4. So that will be 31 plus 64, and that produces 95 grams. So this is the molar mass, PO4. So next thing we will do is that we will now find the mass of PO4 in 0.05. So we look for the mass of PO4 in 0.05 mole, following this formula which says number of moles. So number of moles is 0.05 multiplied by the molar mass of PO4, which is 95. And when we multiply that, it gives 4.75 grams of PO4 minus. So these are the number of grams that we have in the given moles. We look at the principles of dilution. When we are talking about dilution, we have an original concentration of an acid, a base, or a solution which needs to be reduced to a lower concentration, and so it can be diluted with water. And the principle of dilution is based on a relationship, which is that the original concentration multiplied by the original volume will be equal to the diluted concentration multiplied by the diluted volume. These concentrations are mainly carried out in mole per dm cubed, and then the volume is carried out in cm cubed or in dm cubed. And so let's look at a question in that line. It says that what volume of 0.5 molar potassium hydroxide will be diluted with water to obtain 250 cm cubed of 2 molar potassium hydroxide solution. Now in this question, we have an original concentration of an alkali, which is 2.5 molar. We are to find the volume, original volume, and then to obtain a diluted concentration of 2 molar and then a diluted volume of 250 cm cubed. And so what we need to do is to make use of our formula. Now in this formula we are looking for the original volume. So making the original volume the subject of this equation, we have that VO equals to CD multiplied by VD over original concentration. So the diluted concentration, which is 2, multiplied by the diluted volume, which is 250, over the original concentration, which is 2.5. And when we multiply this out, it produces 200 cm cubed. So this is the original volume of potassium hydroxide before it was diluted. Alright, so here's the next question, which says calculate I, the new volume of solution, II, the volume of water added when 50 cm cubed of 0.25 molar solution were diluted to 0.05 molar solution by the addition of water. Now in this question we would really understand what the principle of dilution is about. We have an original concentration of 0.25 molar and an original volume of 50 cm cubed. Then we have a diluted concentration of 0.05 molar and a diluted volume which is unknown. And we have that COVO equals to CDVD. We are looking for our VD. So that will be COVO over the diluted concentration. The original concentration is 0.25 and the original volume is 50 over the diluted concentration, which is 0.05. Now when we multiply this out, it gives 250 cm cubed. Now if you look at all these values, you'll notice that when we had 50 cm cubed volume, the concentration was higher. But when the volume had increased, the concentration of the diluted one has reduced. So we have a low concentration here and we have a higher concentration here. So what we are saying now is that the volume of the new solution is 250 cm cubed. Now it was originally 50, then water was added to become 250. So the big part says that what is the volume of water that was added? So we'll say that volume of water added will be the diluted concentration minus the original concentration, which gives 200 cm cubed of water. Alright, so under volumetric analysis, we shall be looking at titration. Titration is an important part of chemistry, and it describes a process whereby a solution of an acid, which is in a burette, is gradually added into a definite volume of a base inside a conical flask with shaking until the reaction is complete, as it is observed by a sudden change in the color of an indicator which was put in the alkali So we have an indicator. So acid is added gradually into a conical flask containing a base which has a definite volume and particular drops of an indicator. After some time, there will be a color change due to the indicator. The reaction will be complete, which is observed by a sudden change in the color of the indicator. Perhaps the color of the indicator that was put there was blue, and there will be a sudden change from that blue to red. And when that sudden change exists, the drops of acid will have to stop, because that indicates the end point of this reaction. And the end point of this reaction is the neutralization point. The volume of the acid which was added is regarded as the titer value. So there are some things that are important during titration, and it is the fact that the end point or the titer value is the volume at which the acid solution neutralizes the base. We have several indicators that are added to the base, and the choice of indicator in an acid-base titration, it depends on the strength of the acid and the base, whether they are strong or they are weak. So it is important to make the right choice of indicator. We have several indicators such as the blue litmus, red litmus, we have methyl orange, phenolphthalein, we have the bromothymol blue, and so on. And here are the series of color change when these indicators are put in an acid or when they are put in a base. And these are the color changes and their original colors. Now, we have weak acid and we have weak base. So the relationship between an acid and a base in titration can easily be carried out with a formula which says that the concentration of the acid multiplied by the volume of the acid over concentration of the base multiplied by the volume of the base equal to number of moles of the acid over number of moles of the base. This is the formula which we shall use to solve questions regarding titration. Alright, so here is the first question which says 20.30 cm cubed of hydrochloric acid solution was titrated against 25 cm cubed of 0.1 molar sodium hydroxide solution. Calculate I, the concentration of the acid in mole per dm cubed, II, the concentration of the acid in grams per dm cubed. First, let's have an understanding of what the equation looks like. We have acid titrated against a base, which is HCl plus NaOH in a neutralization reaction. Hence, we have sodium chloride plus water. Those are the products. We have this in aqueous form, aqueous, our NaCl in aqueous, and we have our water in liquid. Next is to look if this equation is balanced. And from here, the reactant side, we have one hydrogen and one hydrogen here, which is two hydrogens. And over here, we have two hydrogens. So we have two hydrogen atoms. That means it is balanced. Next is look at the chlorine. We have one chlorine atom and we have one chlorine here. We have one sodium and we have one sodium here. And then we have one oxygen atom and one oxygen atom. Hence, it is balanced. So the reacting acid is 1 mole to 1 mole of a base. Now let's get our parameters. We have concentration of the acid in the question is unknown. The volume of acid given in the question is 20.30 cm cubed, and the concentration of base given in the question is 0.1 molar, and the volume of base given in the question is 25 cm cubed. Then we have our number of moles of acid to be 1 and number of moles of base to also be 1. So we have our equation which is CAVA over CBVB equal to Na over Nb. We are looking for the concentration of acid, and so we'll make that the subject of this equation. And how do we do that? We multiply this with this and this with this. So let's go ahead with this one multiplying this. So that will be CaVa multiplied by Nb equal to CbVbNa. So concentration of acid equal to CbVbNa over VaNb. So we have concentration of base, which is 0.1, the volume of base, which is 25, and the number of mole of acid, which is 1, over the volume of acid, which is 20.30, and the number of moles of base, which is 1. And so this gives 0.1232 molar of hydrochloric acid. Then the B part says that we should calculate the concentration of acid in gram per dm cubed. So first is that for our acid, we need to get the molar mass of the acid, which is HCl, and that is 1 plus 35.5. That is 36.5 gram per mole. And then we have the concentration in gram per dm cubed equal to concentration in mole per dm cubed times molar mass. And so we have 0.1232 multiplied by 36.5, and that produces 4.50 gram per dm cubed. So here is the concentration in gram per dm cubed of hydrochloric acid that took part in the titration reaction. Okay, so we have the next question here, which says 2.65 gram of anhydrous sodium triiosocarbonate 4 were dissolved in water and made up to 250 cm cubed. 25 cm cubed of this solution require 20 cm cubed of hydrochloric acid for complete neutralization. Calculate I, the concentration of sodium triiosocarbonate 4 in gram per dm cubed, II, the concentration in moles per dm cubed. Now, in this question, we have 2.65 gram of Na2CO3, which dissolved in water and made up to 250 cm cubed. In this question, we have that 2.65 grams of Na2CO3 is what we have in 250 cm cubed of the solution. Now, to make it in 1000 cm cubed, because we are working towards making it a molar concentration, so we want to standardize it to make it a standard solution. X gram is what we have, so we do not know it. So X equal to 2.65 multiplies 1000 over 250. And when we multiply this, it gives 10.6 gram per dm cubed. Now, to have it in mole per dm cubed now we've already answered the first part of the question, because we are told to calculate the concentration of sodium triiosocarbonate 4 in gram per dm cubed. So here is the first answer. Then B, to find the concentration in mole per dm cubed, we have that concentration in mole per dm cubed equal to concentration in gram per dm cubed divided by the molar mass. The molar mass of Na2CO3. Here, the sodium is 23 multiplied by 2 plus carbon, which is 12, and then 16 times 3 of oxygen. So we have 46 gram plus 12 plus 48 grams. And when we add all this, it yields 106 gram per mole. Now, our concentration in mole per dm will be equal to the concentration in gram per dm, which is 10.6, over the molar mass, which is 106. And when we divide this, it gives 0.1 mole dm cubed, which is taken as 0.1 molar of Na2CO3. Alright, so here comes the next question. It says 20.30 cm cubed of a solution containing 5 gram of an acid H2Y per dm cubed neutralizes 25 cubic centimeter of solution containing 4 gram of sodium hydroxide per dm cubed. Calculate I, the concentration of the acid in mole per dm cubed, II, the molar mass of the acid, Roman figure 3, the value of Y, and Roman figure 4, the percentage by mass of Y. In this question, we're not given straightforward parameters. So we have that an acid, which is H2Y, neutralizes a base, which is sodium hydroxide. And when this reacts, we will have NaY plus H2O. And here, we will need to balance the equation, even though we're not given the full constituent of the acid. But here we have 2 of hydrogen and 1 of hydrogen here, making 3 of hydrogen. But here we have just 2 of hydrogen. So to balance up the hydrogen, we could place 2 over here. We have 2 hydrogen and 2 hydrogen making 4, and then we have 2 over here making 4 hydrogen. Then we have 2 oxygen here, and we have 2 oxygen here. We have 2 of sodium here, and we have 1 of sodium here. So this has to be Na2Y. And that is what the salt would look like. Now that we have gotten our equation, all these are aqueous, and we have aqueous, and we have liquid over here. Now with that gotten, we have to calculate the concentration of the acid in mole per dm cubed. To get the concentration of the acid in mole per dm cubed, we need to get the concentration of our base in mole per dm cubed. And our base is sodium hydroxide. So the molar mass of sodium hydroxide, sodium is 23, oxygen is 16 plus 1. And when we add all this, it produces 40 grams per mole of sodium hydroxide. And in the question, we're given concentration of the base in gram per dm cubed to be 4. Next, concentration in mole per dm cubed of our base will be 4 over 40, and that's 0.1 molar. Using the formula CaVa over CbVb equal to Na over Nb. From here, the concentration of the acid, which is unknown, then the volume of the acid, which was given in the question, is 20.30, and the number of mole of acid in the question is 1. The concentration of base in this question is 0.1 molar, which is what we've just derived. The volume of the base in this question is 25 cm cubed, and the number of mole of base is 2. Now we make Ca the subject of formula, and then we'll have it as CbVb Na over VaNb. So concentration of base is 0.1, and the volume of base is 25. Number of moles of acid is 1 over volume of acid is 20.30, and the volume and the number of moles of base is 2. Now when we multiply this, it gives 0.0616 molar of the acid. So we've gotten the first part of the question, that is of H2Y. Next, we have to find the molar mass of the acid. Now we've derived the concentration in mole per dm cubed of the acid. And in the question, we're given the concentration of the acid in gram per dm cubed to be 5. So we have that a formula that says that concentration in mole per dm cubed equal to the concentration in gram per dm cubed over its molar mass. So the molar mass will be concentration in gram per dm cubed, which is 5, over concentration in mole per dm cubed, which is 0.0616. And when we calculate this, we will approximately get 81 gram per mole. Now, this is the molar mass of the acid. The next part of the question says we should calculate the value of Y. See, to get the value of Y, we have that molar mass of H2Y equal to 81 gram. Hydrogen is 1 multiplied by 2 plus Y equal to 81. 2 times 1 is 2 plus Y equal to 81. So the value of Y equal to 81 minus 2, and that is 79 gram. And lastly, we're told to find the percentage by mass of Y in the acid. Now that we know that Y is 79 of the 81, so we have that percentage by mass of Y equal to 79 over 81 multiplied by 100, and that produces 97.5%. So that is the percentage of Y in the acid. Alright, so here comes the next question, which says 25 cm cubed of 3 gram of hydrated sodium trioxocarbonate 4 solution, that's Na2CO3.XH2 per 250 cm cubed was neutralized by 13.20 cm cubed of 0.16 molar hydrochloric acid solution. Roman figure 1. Write the equation of reaction. Roman figure 2. Calculate the concentration of base in mole per dm cubed. Roman figure 3. Calculate the molar mass of the base. Roman figure 4. What is the value of X? And Roman figure 5. The percentage by mass of water of crystallization. Alright, so in this question, to solve it, we need to first get our equation. We're told that the sodium triacylcarbonate 4 is an hydrated one, so that's Na2CO3 dots, but we do not know how many water of crystallization that we have. So it reacts with hydrochloric acid to produce NaCl plus H2O plus CO2 because of this carbonate that is over here. Now we do not know how many water of crystallization, and so we have it that X plus 1, meaning that any number we have here plus 1 will give us the number of moles of water that was produced. And so we have this is a solid, this is aqueous, this is aqueous, this is liquid, and this is a gas. So that is the first part of the question. So now after we have gotten that, we will check to know if our equation is near to being balanced. Now in this equation, we have 2 of sodium here, and here we have 1 of sodium. So we can include 2 over here, such that we have 2 of sodium. Then for the chlorine, we have 1 over here, or we have 1 of chlorine here, but we have 2 here, so we can include 2 over here. So we have 2 of chlorine, and we have 2 of sodium. We have 1 of carbon and 1 of carbon over here. Then for the oxygen and hydrogen, those ones may not be balanced completely because of the X which we have here. Next is to go to the second part of the question, which says we should calculate the concentration of base in mole per dm cubed. So we write our parameters. Number of moles of acid, we have 2. Volume of acid given in the question is 13.20 cm cubed. And the concentration of acid that we have in this question is 0.16 molar. The number of moles of base that we have in this question, which is here, and then the volume of base that we have in this question, 25 cm cubed, and the concentration of base is unknown. That's what we are looking for. So we have our formula and we substitute. Now we are looking for Cb. So we can have it that Cb equal to VA over VBNA. So our concentration of acid, which is 0.16 multiplied by volume of acid, that's 13.20 times number of moles of base, which is 1, over volume of base, that's 25, multiplied by number of moles of acid, which is 2. And when we multiply all this out, it gives 0.0422 mole per dm cubed. So here is the molar concentration of the base. Then we go to the C part of the question, which says that we should calculate the molar mass of the base. And in the question, to get the molar mass of the base, we have succeeded in getting the molar concentration, that's the concentration in mole per dm cubed. In the question, we were told that 3 grams of the hydrated salt is present in 250 cm cubed. So we have to find the grams in 1000 cm cubed to make it standard. So we have 3 grams present in 250 cm cubed. Hence, in 1000 cm cubed, how many grams are we going to have? So we have x equal to 3 multiplied by 1000 over 250. So we have 12 grams per dm cubed. Next, we can get the molar mass. We have that concentration in mole per dm cubed equal to concentration in gram per dm cubed over the molar mass. So making molar mass the subject of this formula, we will now have concentration in gram per dm cubed, which is 12, divided by the concentration in mole per dm cubed, which is 0.0422. And that will give 284 gram per mole. So here is the molar mass of the base. So next, we have to calculate the value of X. So now that we know the molar mass of X, we will say that Na2CO3.XH2O is equal to 284. Sodium is 23 multiplied by 2 plus carbon, which is 12, plus 16 times 3. Alright. Then plus X into brackets 2 times 1 plus 16. So this X multiplies this, and that would give us 284 in all. Here we have 46 plus 12 plus 48 plus X into brackets 2 times 1 is 2, 2 plus 16 is 18, equal to 284. When we add all this, it gives 106 plus 18x equal to 284. So 18x equal to 284 minus 106, and that gives 178. So x equal to 178 divided by 18, and that produces 9.89, and that's approximately 10. So the value of x in that equation is 10. Now we are asked to calculate the percentage by mass of water of crystallization. Now the water of crystallization, which is the E part of this question, the water of crystallization, which is that of XH2O over Na2CO3.XH2O times 100. Here, the XH2O, if you look for all this, we could use 9.89 multiplying the total molar mass of H2, which is 18, over all this, which we calculated over here to be 284, times 100. Now if we multiply all this out, we will get 62.7%. So that is the percentage by mass of water of crystallization in this particular hydrated salt. Alright, so we shall be looking at the subtopic percentage purity and impurity under volumetric analysis. Now it is possible that a solution could contain impurity, that is the acid or the base, and so these are contaminations of salt and the likes. Then it is important to also note that even though these impurities are present, it is the pure part of the acid and the base that will react to form your salt and water. Now, the impure solution, for instance, the impure solution is equal to a sum of concentration of impurity plus concentration of the pure solution. So when you add the impurity plus the pure solution, you arrive at the impure solution, and you can calculate the percentage purity by saying that concentration of the pure solution over concentration of impure multiplied by 100. Likewise, we can calculate the percentage impurity by saying that concentration of impurity over concentration of impure multiplied by 100 over 1. So this is the pure concentration, while this is the total, that is the total of impurity and the pure. Why this percentage impurity is concentration of the impurity over concentration of the total. And so in these aspects of volumetric analysis, these are the basic formulas we will be using to solve questions. Alright, so here comes the first question. We are told that 25 cm cubed of a solution containing 3 grams of impure sodium hydroxide in 250 cm cubed was neutralized by 30 cm cubed of 0.1 molar tetraoxosulfate 6 acid solution. Calculate Roman figure 1, the concentration of the pure sodium hydroxide in moles per dm cubed. Roman figure 2, the percentage purity of sodium hydroxide. Roman figure 3, the percentage impurity of sodium hydroxide. And Roman figure 4, the number of moles of hydroxyl ions present in the pure sodium hydroxide that reacted. Alright, so in this question, we have a base which was neutralized by an acid. So first, let's get our equation. We have sodium hydroxide plus H2SO4. That produces Na2SO4 plus H2O. Alright, so we'll check to see if our equation is balanced, but obviously it is not balanced. Here we have 1 of sodium and here we have 2 of sodium. And so if we place 2 over here, we have 2 of sodium now, then we have 2 oxygen plus 4 oxygen making 6. We have 4 and 1 here. And so we could place 2 in front of water here, and then so oxygen is balanced. And next we have 2 hydrogen atoms, we have 2 here making 4, and then we have 4 over here. Now the equation is balanced. Next, we have to calculate the concentration of the pure sodium hydroxide. Now in this question, let's state our parameters. Number of moles of acid, here we have just 1. Number of moles of base, this is the base, which is 2. Concentration of acid, which was given in the question, we're told is 0.1 molar. So here is 0.1 molar. Then concentration of the base, it is what we are asked to look for. Volume of acid that was given in the question is 30 cm cubed, and volume of base that was given for us to use is 25 cm cubed. Now with this information, we have it that CAVA over CB VB equal to NA over NB. Now we are looking for CB, so we'll make CB the subject of this equation. Alright, so we have it that CB equal to CA VA NB over VB NA, and then we substitute our values. So CB equal to concentration of acid is 0.1, volume of acid in this question is 30 cm cubed, and number of moles of base we have it as 2 over volume of base in this question is 25 multiplied by the number of moles of acid is 1. Alright, so with all this we calculate this and we'll have 0.24 molar. Here is the number of moles of the base. So we've gotten Roman figure 1, that's the first part of the question. Now, the Roman figure 2 of the question says we should calculate the percentage purity of sodium hydroxide. This is the number of moles of sodium hydroxide. And in the question, we're told that we have 3 grams of impure sodium hydroxide in 250 cm cubed. Okay, so what we have to do next is to calculate the molar mass of sodium hydroxide. We'll relate the 3 grams in 250 cm cubed to become 1000 cm cubed. Alright, so let's calculate the sodium hydroxide molar mass first. So the molar mass of sodium hydroxide, we have our sodium to be 23 and oxygen is 16 plus 1. And so when we add all this, we have 40 grams per mole. Next, we are told that we have 3 grams of sodium hydroxide in 250 cm cubed, which is the impure solution of sodium hydroxide. How many grams of sodium hydroxide are we going to have in 1000 cm cubed? Now we want to make it standard, and so we have x equal to 3 times 1000 over 250, and this produces what? We have 12 grams per dm cubed. Here is the concentration of the impure sodium hydroxide. Now here is the concentration of the sodium hydroxide, of the pure sodium hydroxide in mole per dm cubed. Alright, so next thing is for us to determine what is the gram per dm cubed of the pure. So we have this one as the impure sodium hydroxide, and this is the pure. So we want to get this one in gram per dm cube now. So we have that concentration in mole per dm cubed equal to concentration in gram per dm cubed over molar mass. So our concentration in gram per dm cubed equal to 0.24 multiplied by the molar mass, which is 40. And so we'll have it at 0.24 multiplied by 40, and that gives 9.6 grams per dm cubed. Alright, so this is now the pure. This is the pure NaOH in gram per dm cubed. Alright, and then this is the impure, and this is the pure. And so next we have to calculate the percentage purity. So we have it that percentage purity equal to concentration of pure over concentration of the impure. And don't forget now that we are using the gram per dm cubed for both of them, of the sodium hydroxide, times 100. Now concentration of pure is 9.6 and the concentration of the impure is 12 multiplied by 100, and when we multiply this it gives 80%. So this is the second part of the question, telling us the concentration of the purity. Then the third part of this question is to find the percentage impurity of sodium hydroxide. Now, if 80% is the purity, so we can have that the impurity will be 100 minus 80%, and that will be 20%. So this is the percentage impurity. But if we are told to find the concentration of the impurity, so the concentration of the impurity in the entire solution, we'll have it as 12 gram per dm cubed minus 9.6 gram per dm cubed, and that will produce 2.40 gram per dm cubed. So this is the concentration of impurity. Last part of the question says that what is the number of moles of hydroxyl ions present in the pure sodium hydroxide that reacted. Alright, so for us to get the number of moles of sodium hydroxyl ion present in the pure sodium hydroxide, now we first need to understand that sodium hydroxide, when it dissociates, is Na plus OH minus, and that means we have 1 mole of sodium hydroxide producing 1 mole of sodium ion and 1 mole of hydroxyl ion. And we have derived in this question that the concentration of sodium hydroxide in mole per dm cubed equal to 0.24 molar, right? Meaning that if you have 0.24 molar of this per dm cubed, but if you go back to the question, we have that 25 cm cubed of that solution, okay, of a solution, okay, 25 cm cubed of a solution containing 3 grams of impure sodium hydroxide in 250 cm cubed was neutralized. So this is actually 0.24 mole per dm cubed, but we are dealing with 250 cm cubed now. Okay, if in 1000 cm cubed we have 0.24 mole, hence in 250 cm cubed, how many moles do we have? So we have it that X equal to 0.24 multiplied by 250 over 1000. That's 4. So 0.24 divided by 4, that produces 0.06 mole in 250 cm cubed, okay, of sodium hydroxide. So hence, if 1 mole gives us 1 mole of sodium ion and 1 mole of hydroxyl ion, we will hence have that 0.06 mole of sodium hydroxide will also produce 0.06 mole of hydroxyl ion. So here is the final answer, and that is the fourth part of this question. Alright, so this next question says 3.5 grams of a dibasic acid were dissolved in distilled water and made up to 250 cm cubed. 20 cm cubed of this solution neutralized 35.40 cm cubed of 0.2 molar sodium hydroxide solution. Calculate Roman figure 1. We have to write the equation of reaction, and Roman figure 2, the concentration of the acid in mole per dm cubed, and Roman figure 3, the molar concentration of the dibasic acid. Alright, so we were told that a dibasic acid, meaning that it has 2 hydrogen. Alright, so we have a dibasic acid, so we can have it as H2, let's make it X, was dissolved in water. So when it was dissolved in water, you have 2H plus X2 minus. So here we have aqueous, and we have aqueous over here. Next, we were told that this neutralized sodium hydroxide, and so we have H2X plus sodium hydroxide to produce Na2X plus H2O. And next is for us to balance this equation. The fact that we have we have 2 hydrogen molecules, 2 hydrogen atoms, and 1 here, and here we have 2. And so we could balance it up by having 2 here and having 2 here. So we have 2 times 2, that's 4 hydrogen. We have 2 hydrogen and 2, making 4. And then the sodium, we have 2 and we have 2 here. So it's just the X that we need to finally get. And then the oxygen, we have 2 atoms and then 2 atoms here. So that is also balanced. Next, that is the first part of the question. The second part of the question says that we should calculate the concentration of the acid in mole per dm cubed. And so let's state our parameters. Number of mole of acid that we have in this question, we have 1. Number of moles of base, we have 2. Concentration of acid that we have in this question is unknown. That's what we are looking for. And concentration of mole of base in this question we were given as 0.2 molar. And volume of acid in this question we were given that 20 cm cubed of it. So 20 cm cubed. And then the volume of the base we were given as 35.40 cm cubed. And so we have our formula as CAVA over CBVB equal to NA over NB. We have to find concentration of acid. So we make concentration of acid the subject of this formula by having CBVB NA over VA and then NB. From here, we would substitute our values into this. So the concentration of base in this question is 0.2. The volume of base in this question is 35.40, and the number of mole of acid is 1 over the volume of acid in this question is 20. The number of moles of base in this question is 2. Alright, so we have it that, and then so when we calculate all this, it produces 0.177 mole per dm cubed of acid. So that's the concentration of acid that we have in the question. So we've gotten the second part of the question. Now the third part says we should find the molar mass of the dibasic acid. We do not have the complete formula of the acid, but we have the concentration of the acid, and we could also get the concentration of the acid in gram per dm cube. And so from these two information, we will be able to get the molar mass of the acid. Now we were told that 3.5 gram were dissolved in 250 cm cubed. So if 3.5 gram were dissolved in 250 cm cubed, to make it a standard concentration, we have in 1000 cm cubed, which is x. So x equal to 3.5 multiplied by 1000 over 250, and so this produces 14 gram per dm cubed. Now we're not told of any impurity that were present in the base or in the acid. Right now we have it that concentration in mole per dm cubed equal to concentration in gram per dm cubed over the molar mass. So from this information, we will use the molar mass. We will use this to derive the molar mass. And so we will have that the molar mass equal to concentration in gram per dm cubed, which is 14, over the concentration in mole per dm cubed, which is 0.177. And when we divide this, it produces 79.10 gram per mole. So here is the molar mass of the acid H2X. Alright, so we have a next question here, which says hydrochloric acid solution was prepared by diluting 10 cm cubed of 10 molar hydrochloric acid to 1 dm cubed. Calcium hydroxide solution was prepared by diluting 10 cm cubed of the saturated solution to 100 cm cubed at room temperature. Given that 20.10 cm cubed of the hydrochloric acid solution neutralizes 25 cm cubed of calcium hydroxide solution. Calculate, Roman figure 1, the concentration of hydrochloric acid in mole per dm cubed. Roman figure 2, the concentration of calcium hydroxide in mole per dm cubed. And Roman figure 3, the solubility of calcium hydroxide at room temperature. Alright, so in this question, we have hydrochloric acid, which reacts with a base, that is calcium hydroxide, and that produces salt and water. Next is to look if this equation is balanced. From here, it is not balanced because we have one of chlorine atom here and we have 2 atoms of chlorine here. And so if we place 2 over here, we have 2 of hydrogen, and we have 2 here, we have 2 here. So if we have 2 here, and we have 2 of oxygen, so the equation is balanced. Now we have to calculate the concentration of hydrochloric acid in mole per dm cubed. Now for the acid, we were told that originally we had 10 molar with a dilution of 10 cm cubed, but it was further diluted into 1 dm cubed, which is 1000 cm cubed. Using our principle of dilation, which is COVO equal to CdVd. Now the original concentration was 10 and the original volume was also 10, and the new concentration, which is the diluted concentration, is unknown, and the diluted volume is 1 dm cubed, which is 1000. And so we have the CD equal to 10 times 10 over 1000, and this produces 0.1 molar. So this is the first part of the question, that is the concentration of the acid in mole per dm cube. Now the second part says we should calculate the concentration of the base, that is calcium hydroxide, in mole per dm cubed. Now for us to get this done, we will state our parameters. Number of mole of acid in this question is 2. Number of mole of base is 1. Concentration of acid that was given in this question, we have 0.1. Concentration in mole per dm cubed of base is unknown, that's what we are looking for. Then the volume of acid which reacts in this question, we have it as 20.1 cm cubed, that's okay. And then the volume of base which reacts in this question is 25. So we have concentration of acid, volume of acid over concentration of base, volume of base, equal to number of mole of acid over number of mole of base. So we are looking for this, and so we'll make it the subject of this formula, and that will be concentration of base equal to CaVaNb over VbNa. Next is to substitute our values into this. So concentration of acid here is 0.1. Then volume of acid, we have it as 20.1. Then number of mole of base is 1 over the volume of base in this question, which is 25, and the number of moles of acid, we have it as 2. And so when we multiply all this, it produces 0.0402 molar. So here, that is the concentration of the base in mole per dm cube. Now the third part of the question is to calculate the solubility of the base at room temperature. Now when we go back to the question, we had an original concentration of the base, which is 10 cm cubed, and we have an original concentration of the base which is unknown. It was diluted into 100 cm cube volume, and the new concentration, that is the diluted concentration, is what we've just derived here, that is 0.0402. So we are looking for the original concentration of the base, and we are going to make use of this particular formula. Original concentration of the base will be equal to CD, which is 0.0402, multiplied by the diluted volume, which is 100 over 10. When we multiply all this, it produces 0.402 molar, or 0.402 mole per dm cubed. So that is the solubility of calcium hydroxide at room temperature.